Okay, everything ready. So we can start. Hello, my name is Rodrigo. Many of you already know me, but for those who don't know me, I'm studying computational neuroscience in Unicamp, and my areas of interest are statistical physics, machine learning, data science, all those computational crafts. So the seminar will be based on this notebook. I don't know how many of you already know Jupyter Notebook. Jupyter Notebook is a platform to organize your ideas and codes and put images, text all together in cells. As you can see, I have a cell with an image, a text, and right behind a code cell. So you can organize your ideas very clearly. And so for data analysis, perfect. If you have any question, you can just ask. I prefer if you open your microphone, that's not a problem at all. But if you want to write in English or in Portuguese, it's okay, no problem. I will try to answer it. So let's begin. First of all, it's important to notice the libraries that we're going to use. So in Python, there are many libraries that can fit a good model to use for data analysis, but there are 5 that are the most important ones. So the first one is Numpy, the second one is Pandas, the third one is Matplotlib, and the last one is Scipy. I don't know how many of you already know Numpy because it's a very famous library. I think that's the most famous library in Python. So actually, if you can tell me how many of you already know Numpy. You can write on the chat. Okay. So okay, so I can see that some of you already know, but okay, so yeah, some of you already know. For those who don't know, Numpy is a library that is basically the base for mathematical operations in Python, and the best mathematical tools with best precision. There's the best library to numerical methods, integration, and solution for linear and nonlinear equations. But for us, the most important part of NumPy today will be a data structure called array. NumPy introduced this data structure on Python, and that's a very important data structure that we're gonna use basically all the seminar. And if you want to do an analysis on Python, you need to use arrays. So what is an array? Array is basic a vector, a coordinate vector in Rn, which means that you can, for example, multiply by a scalar. You can sum 2 arrays and result in another array with the same dimension. It's very different different of the lists in Python, because lists in Python, if you multiply by a scalar, for example, in this code here, you can see that there is an array and multiply by 2. If you would do this with a list, the list would double in size, and we don't want that. We want that when you multiply by a scalar, you multiply all the coordinates inside the vector. So when I run this code, sorry, I didn't import the libraries. So when I run this line of code here, you can see that we are going to multiply all the, we are going to multiply all the components of this array by 2. So it is exactly like a coordinate vector. You can interpret this way, not a problem at all. And sometimes we are interested in slicing the arrays. So we are interested in only in a part of the array. So we can use this artifact here. You can see with this notation to symbolize what part do we want of the array. So here, the array errors have 5 components. It's important to remember that Python starts on the 0 component, not the first. So this is the 0th component, the first, the second, the third, and the 4th component. So when we write errors with this syntax here, what we are saying is we want the first component from the first component to the 3rd component. But why not the 4th component? Since here is row 4. Python, and I don't know why, make the interval open on the last number. So here is 1 from 1 to 3 to the 3rd component. As you can see here, let me erase this line here. If you look here, we have the, sorry, let me execute again. So if we check here, we have all the components here. Wait a minute, just 3. And sorry, let me get back here. What I'm doing here, sorry, just misunderstanding. What I'm doing here is that I'm multiplying this slice of the array by a cosine, just to show you that you can multiply by cosine functions, and to show you that if I multiply this slice of the array, as I said, from the first to the 3rd component, we will see that when you print the array, the error array, you can see that the first, the second, and the 3rd components are changed. So what happened was we sliced an array and multiplied it by a number. So our part of interest was multiplied by this number, and not the part that we are not interested. So we can see that the 0th component and the 4th component is still the way that we declared. So we changed just a part of the array. So to make the slice thing more practical, we can see a variable that we're going to create called slice errors. So I will declare this variable equals errors. And when I don't use any number here, so wait a minute, I think that stopped it for me. I don't know why. Let me screen share again. I don't know why this is happening. Okay, we are back. I think, yes, we are back. Someone please confirm to me. Okay, so so again, to make this slicing of array more practical, I'm going to declare this variable slice zeros, and here in this syntax, we are picking the first component, the 0th component of the array until the 2nd. Remember that it's an open interval on the right side. So I will pick a slice of the error variable that we declared. And here I'm going to change just the 2nd component and turn to 0. So I will print the slice errors variable that we created here. And we can see that's indeed the 0th, the first and the 2nd component. remember that the second component return to 0. So here it's important to remark that when we write the variable that we declare first, so if you print error, you'll see that the second component is still 0. So we declare the slice errors and then turn to 0, but we changed the first variable that was errors. That happens because in Python, there's an important thing that is called reference. And here, when you declare this variable equals this slicing of error, what we're doing is a reference, not a copy of the array. So when we change a component of slice errors or we change a component of errors, we are changing the same components for both of them. So if you need to make a copy and you don't want to have this problem, you can just write this line of code here, np.copy, and you can execute, and you'll see that it's a copy, not a reference. So if you change any components, you don't change the component on the first array. So that's very important to know, because you can screw everything up just by changing a number somewhere in your data. So, okay, let's go to the creation. There's something on the chat, really interesting. Okay, thanks. So let's create the X, Y, and sigma Y values to try to fit a model, a simple model first, and then we can go to more complex and put into practice. But that's just for you learn basically how the library works. So here we can create X values with this function, linspace. The first entry here means the first component of the array that you want to create, and this is the last one. And the third entry means what step you want to go from 0 to 100. So if you see here, since we are counting the 0, we go on 11.111111 step size of the steps. If you want like close numbers, you can do this and put 11, and then we'll get it. But let me use 10. So here, the model. So I define this function here, just a linear function, basic linear function. And let's create the Y values here by just using this array that we already created to create the Y values. And here to create the sigma values, I'm going to use another important thing on Numpy. That is, you can create numbers, random numbers, because that's a very complex subject on computer science. But Numpy has a solution for this. And we can create the random values in a uniform distribution on this interval that I wrote here. Low is the lowest value, and high the highest value, and size the size of the array that I want to create. So here we can create the sigma random values. And now we have the X value, the Y value, and sigma Y value. So next, let's look to the Scipy library. Scipy library is basically a library to problems for optimization, regression, interpolation, many functions that we are going to use, for example, the regression function. And if you check the reference, this library is enormous, so you can explore all the features. So all you're going to use of the Scipy is optimization and regression. So I recommend to check all the others functions So here we are going to use the curve fit method, which make the ordinary least square. I think many of you already know this regression technique. It's important to know that just consider the sigma y error. So you can do this only for data in the sigma y with sigma y errors. So let's fit let's fit these values that we created here. So let me run this code. Here is the first line here is the parameters guess, and the second line here is the curve fit code. So you need to put optimization dot curve fit, the function as a first entry, the second entry x, y, p0 is the first guess, sigma is the error, and absolute sigma go through if you want absolute sigma. So let's do this, and we can see that fit variable are made of two arrays. The first array are the coefficients, the coefficients that the parameters that the fit encountered, and the second array is the covariance matrix. Just like any software, you get the covariance matrix and you get the parameters. If you want the errors of the parameters, it's very easy to do. Remember that this notebook will be available on a Drive link, so anyone can just download it and look the steps. So you don't need to write anything. You could just open. So I will share the link right now to you. You just click the link and download this notebook. So to study after this. So here we get these two arrays, and let's make the things more presentable. So in the first line here, let's pick the A value and the B value of the parameters, since we are dealing with a line, a linear model. So we can get the errors of the parameters using the concept of the errors using the covariance matrix. So it's the square root of the diagonal of the covariance matrix. Numpy can make the diagonal for us, the square root for us. That's not a problem, just one line of code and you have the answer. So I will show you how this variable looks like. So I will print the standard defs here, and you can see the errors of the parameters. So to the first parameter is this error, and the second parameter is this error. Just remember the parameters was in the function here. So f and b and a as the parameters, and when you define it. I am assuming that many of you already know Python. So if you don't know what I'm saying, you can just ask and I go back and explain again. So here we have the chi-squared, which is incredibly low since the data we create is doesn't have any noise. We just create this data with without any random generator, just for the sigma, and the sigma doesn't can much. So we are going to use real data after, but for now it's just to understand the libraries. So to continue, I introduced another library, which is Pandas, and I will use Pandas here just to make the things more beautiful to look, which means make sheets with the parameters and the uncertainty. And I will use to import the data later. But you can see that's very presentable this way, and you can see in a beautiful way the guess of the fate. And then matplotlib, which is the Python, the most Python plots graphic interface library. So here I'm going to plot the plots. Here we can see the figure. Okay, so that's pretty simple. You can see the model. You can see the dots, which is our data in red, and the model in black here. So to have a look on the code, we can see it is quite simple. The names of the functions are intuitive. So plots, the first entry is our array. The second entry is the y values. Label is model, as we see here. The color is black. Error bar are the data points here, the red data points. So color red. This is the way that we want to show. So we want to show the data as points here. The label of the axis, and two legends, and the last line of codes to just save the figure. So we are saving the figure as in your file, in our notebook file directory. So it's in the same directory of the notebook. And you can see here on the notebook, that's pretty beautiful. And the residuals here too. The line of code doesn't change much. So you can see the residuals there. So some additional information about the libraries that we introduced in this first part. Since all these libraries are getting famous over time, they are getting they are getting much content every year, actually every week. So I encourage you to search information on the reference on Stack Overflow too, because every day there is a new feature, a cool new feature that you can use. You can see in the Stack Overflow traffic question, you can see that in the past few years, Pandas and Numpy, Matplotlib, all these libraries are getting really famous. So I encourage you to find this information. And I recommend two videos. Actually, one video that's a good video about curve fit in Python that used the first method that we saw, which was the curve fit, and another one that is an article on a good site that do exactly the same thing as the video, but it's cool to see another interpretation of the same thing. So now the second part is putting into practice. That is basically what we do on the disciplines of experimental physics. I will use like real data to do this, data that I collected from our experiments in the last semester. So to make this more real and more practical. So here I using Pandas that we saw to import the data on a TXT file and on a CSV file. So first, this line of code here, we can just write PD, which is the abbreviation for Pandas, dot read CSV, and then write the name of the file and the separation here, which is for TXT, this syntax here. It is important to remark that the file needs to be on the directory of the notebook. So it's not a problem, it's just a remark. And we can see here by this code here, data.head, the first 5 elements of our data. And if I erase heads, we can see all the data here. But I will maintain head just to see that if it is imported well. You can see that it's already labeled and it's all in centimeters. I labeled on the Excel or maybe on the TXT file. I don't know, you decide. Here I will import the CSV directly from Excel or Google Sheets. That's no problem. Just make the table or the sheets and download it as CSV and put this file in the directory of the notebook file. So you can see exactly the same thing, basically no difference. I prefer always to use the CSV file because we see that the CSV file is exactly equals to the Google Sheets or Excel file. So, okay, if you have any question, you can just ask or write on the chat. That's no problem. If I'm going too fast, I don't know. So, okay, so let's pick the values from the CSV, also from the variable data. So here I'm going to pick the X value and the Y value to see how our data is, how our data looks like. Since we imported the data, we want to see that it is really the data that we choose. So here is very simple syntax. You just need to write data and the name of the column that we want. For example, X and Y here. Need to be exactly as is written here. And let's run this code. I will make a scatter plot. Scatter plot means just the points that we want. So I will do the scatter plot just to see the face of our data. And you can see that's a parabolic curve. And the data apparently have noise. So you can see that's not exactly a parabola, which we expect because this is a real data from an experiment. So we see that, okay, so data is cool, and we can go to the data analysis finally. So here we're going to define the function, and to define the function in this case, usually we do this with an array. So let me show you what I mean. So here, when you define the function, and the first input is an array, and the second output is an array too. So when you do the return of the model, look, this is a parabolic model. You can see that we are using the first coordinate of the array here as the first parameter, the second coordinate here of the array as another parameter, and the second as another parameter. So we are interpreting our parameters as arrays, different from what we saw here, that we used the function with the parameters all spared. So X was an array, but B and A was just numbers, float numbers in Python. Okay, so here we have this model, and to make the code that I will show you works needs to be exactly like this. So needs to be exactly like the first input is the parameter array, and the second is the X values. So if you want another model, for example, you can just write here like a polynomial of third degree, and we see that's just write another coordinate, and there is no problem with that. You can just write this. So let's execute this cell and use the values of xy and sigma x and sigma y. I'm going to use exactly the same syntax that we use here to this line of code here. So we just write data, and then we write the label name of the column. So there is a question inside. There is where you write the function to this. There is where I didn't understand your question. So can you rewrite your question? I didn't. Yeah, okay, so we're defining here. The first you mean, or the second? This is the second function that I want to just. You mean right here? Okay, that's okay. So 32. Okay, I don't know what you mean. Are you defining the function? Is where you write the one to just. You mean like where I write? You mean like the cell that I'm writing? Is that what you mean? Where? Because if it is what I'm thinking, doesn't depend where you write it. Okay. Okay, I think that I got it, what you asked. Okay, so I think that your question is when I write this function, which is the second one because I used the first one, I wrote right here behind the important data, and I think that doesn't matter because that doesn't matter actually because the cells, they are independent in a way that if I run this cell with a new function f, is defined a new function f. So the past one that I used, it's ignored since I assuming a new cell with the function f. So it doesn't matter where I wrote this. I can actually wrote right here behind, like in the final of the notebook, and doesn't matter. So I don't know if I answered your question or not, but I think that's what you asked. So if you want to write again, I can read it. Okay, so you continue if you. Tá. Okay, this is the function that I will fit in the data here. So okay, so the parameters are this. So P0 is one parameter, P1 is another parameter, and P2 is another parameter. They, yeah, this is the model, and which means that is a parabolic model in this case, where P is an array. So that's exactly what is happening. P as the first input as an array, and next the other output as an array too. If you want to change the model, again, we can use another component of the array. So in this case, the third component, the fourth component, multiplying what you want actually. Doesn't need to be a polynomial. You can just write anything that you like. So like a cosine, for example, and that's your model. It's important to notice the coefficient will be in this case the second element, the third element here of the array. So you can change your model as you want, since you write the parameters in the right form. So here we wrote a parabolic model, and we can use the values from the data that we picked. So here I run this cell, and now we have the X data, the Y data, and the sigma. Just to show you that we really have the sigma. We can see here, okay, so the sigma data is stored here in this variable. And this is like an array, not exactly an array, but the interpretation is the same, so you don't need to worry about that. So if you multiply by 2 this, you multiply by 2 all the elements, just like an array, so you don't need to worry about this. Just for a curious fact, the name of this data structure is a series. It looks like this table here that we use in Pandas, which is called data frame, the data structure name, but it's just one column of the data frame, and it's almost like an array, so you don't need to worry about it. Okay, so now we are going to fit the model to the data, and I use the orthogonal distance regression, but you can use the total least squared. As you already probably know, the total least squared is a method that can use errors in the two variables, the two independent variables, the X and Y. So it's different from the ordinary that we saw earlier, but I'm gonna use the orthogonal distance regression for 2 reasons. The first reason is that in the undergrad experimental physics disciplines, doesn't matter actually if you're using total least square or orthogonal distance regression, since the results will be the same always. Not exactly the same, because there are some difference, but almost the same. So you don't need to worry about that. I checked it many times. You can do the total least square too. It's just more boring to do it because you need to write the code. It is easy to find on the internet, but since Scipy has incredible code for the orthogonal distance regression, and is a very useful way to do this regression, I will use it. So you are free to use too. But if you want the total least squared, you can find the codes in a GitHub. I think that's a code for the total least squared. Yeah, I think that is. And you can check the difference here too in this link. So, okay, the code is very basic and is like copy paste, because if you do this, those steps here, so write the values, X, Y, sigma X, sigma Y, and define the model in this way, you just need to copy paste this every time you're gonna use and just change the parameters. So just to explain briefly this code, we define a model which the input is f, the same function that we defined here, a real data object, which means you just define what the data you're using, so x, y, sigma x, sigma y. And here we set up these objects that we created, so the data, the model, and the parameters. So here I used 1, 1, 1 as the guess of the parameters. I chose 1, 1, 1 just because that's a simple regression and we don't need to care much about the guess because they will find a minimum for this function. But if you need to be alert if your guess really have the same components as you have parameters. So here in this case, we have only 3 parameters. So if you want like 4 parameters to another function, maybe a polynomial in the 3rd order, you can just write another one. And this is in order. So the first component here is actually the first parameter that we defined here. So P0, so the first one is the guess for the P0, the second is the P1, and goes that way. So the last one here is set job, which defines the regression they are making, and just run and print the regression. So let's run this cell. And when we run the cell, there are some information that the Scipy gives to us. The first one they call beta, which is the parameters. So the first parameter is here, the second here, and the last one, the third parameter is here. Scipy already calculate for us the error of the parameters. So the first error is here, the second here, and the third here. Quite simple. The beta covariance, which means the covariance matrix, are here. So you can see that's a little like dislocated, but not a problem. You can see all the informations. And here we have the residual variance, and the residual variance means basically what t-squared is talking to us. So the goodness of the fit. The same logic applies. So if you have low values of residual variance, you have a good fit, or your errors are high. So the interpretation is the same, basic. So there is no problem dealing with that. Inverse condition is something that's beyond the scope of this course, and they explain some reasons for halting, and beyond the scope of this course too, too much information. So since we know the values of the parameters, we can just copy the values, the parameters, to plot the graph. So to make this simple, I will just pick the values here to create a variable called YI, just to make the line of the model. Just to make this line here, I will run this and run this to show you. So we create the YI just to create this line red here, this red line here, which is the model, and the black dots are the data points with error, error in the format of a cross. And we see the variance, the residuals here. So we can see clearly that's a data from an experiment with very noisy data, very noisy, not quite noisy, but compared to the last one, which was created by us. So that represents a noisy data. So there are the two graphs here, and we saved the first graph in this line of code here, save fig, in this case exemplo.png, in the same file directory of this notebook file, and the same for the residuals, same thing. So they are saved on the directory already with a good resolution. Here in the notebook, you can actually see with more details the points. For example, here, I want to see with more details. They give the value to us. Here, the values of the points or the line or in the regression. So quite useful if you want to look more precisely at the data and the model. So that's it. The code to the graph is copy pasted too. So actually, this notebook is a guide to just copy paste, and if you are not going to do anything more complex, if you want just to fit data in a model, is like copy paste in this case. You can change some aspects of the plot. For example, here, color, you can put the color you want, the marker style as you want, the labels. And there are some cool features to plot the graph too. You can just see the reference. If you see the reference of matplotlib, you'll find nice features to make beautiful plots and those kind of things. But here I just prefer to make things simple, to make the code more simple, more clear. So basically, this is the process to fit a model. And the basic libraries that we use. You can find another libraries that do this for us, but in this case, you can do good enough with just this 4 libraries. So if you have any question, you can just ask. The notebook will be available on the drive link that I wrote, but I will write again. So here, the notebook is available there. You can just check, and if you have any question, you can ask me. I will put my email here. So if you have any question about, you can ask me on the email. So that's it. If you don't know Python, that can be a complex in a sense, but it's just another, it's not a rocket science. It's quite simple. You need just to focus and look the steps one by one, and it would be great. So again, it's quite the copy-paste code that I wrote here. So I think is that basically. Okay. Okay, that's a very good question. And I discovered this like this year. If you write here in the first cell, you can see when we imported the libraries, you can see this line of code here. Matplotlib notebook. That's this line of code creates for us like this beautiful interface of graphs, and that's pretty cool because you can actually download the graph here on the notebook, and you don't need to actually write this line of code to save the figure. Pretty cool. So okay, Andres. Okay, so that's a good question because Jupyter Notebook is awesome to organize the ideas as you wrote, but in complex projects, it can be messy and quite slow. So there is some good answers to this. The first one is when I'm using Jupyter Notebook to make complex projects, you can actually import one project on the notebook to another. So you don't need to write all the things in just one notebook. You can just make another notebooks and import all of them in just one that you want to run your code or run a more important thing on your project. So you can import and the things don't get messy that way. So that's a good option. And the second option, it is the Google Colab, which is basically the same thing that Jupyter Web, but it's organized the things more clearly, almost like Overleaf. If you already you've already wrote something in Overleaf, you know that you separate like the projects in various sub files, and you can do this in Jupyter Colab. It's amazing, and you just don't need to get out of your file to do this. You can do this in the project. Here you need to import the projects. So that's it. Okay. Okay, so Guilherme, that's a great question. So, okay, so this is a quite uh, boring part. Actually, it's the most boring part, which is the data. So here you can see that I just imported in a single line of code, and it was beautiful. You can see that's okay. You all the columns are labeled perfectly. I don't need to say anything to Python to make this the way it is. So that's why uh, I did this in this way, because I want to show just the line of the code that makes perfect. But if your data is not organized well, you're going to have some troubles. For example, what you asked, if I want to show the program that I want to start in a in, for example, row 5. So, for example, here you can write skip rows equals to 4. So the pandas will interpret as you are skipping the first, the second, and the third, and the fourth rows, and starts on the fifth row. So uh, that can be a way to do this, but you need to check the reference, because I always get a data on Google Sheets or Excel, because the data will just it's easy to just organize and label the things and just import to here, and you don't need to worry about the messy codes to skip rows or to tell to start in another. So I recommend you to do this, but you can try to find there is some text about it. Yeah, I think yes. I don't know if organize it manually, because if you have a lot of data, that can be complex, but data cleaning is really sucks. So uh, you can find this on the overflow and those kind of things easy, but the things get messy. So I rather prefer to use Excel or Google Sheets to just organize and import to here. So Danielle has a question. So which literature and videos do you recommend for learning data analysis beyond the point you have? Okay, that's good. Good question. And I will answer uh, with the knowledge that I have now and not what I did in the past. So I usually recommend, especially if you are from São Paulo University, is to look on some Coursera's courses. There are pretty good ones, like Introduction to Data Science of Michigan University, University of Michigan. Um, you can check that. Pretty good. I recently finished this course, and it's incredible. They teach you almost all of these libraries in more depth. But I can recommend some other good examples of literature. Here, there is this site here, Towards Data Science. This site's amazing to all of those libraries that we look at here on this seminar, because when when you are dealing with data science, you have a lot of literature, but the literature can get messy. As I was answering Guilherme, the things can get messy on Stack Overflow. For example, you can see like many codes and you don't understand the codes. You run the code and it doesn't work. So it's really important to find these fonts to get good information. This case, Towards Data Science, it's very detailed, and They present you a lot of math, a lot of practical exercises. They explain intuitively all the functions. It's awesome, pretty good. So I recommend you to do a course like the course that I said is just introduction to data science in Python. It's just that. And this site that is in the notebook called Towards Data Science. It's amazing. Maybe I can edit the notebook later and put some other things, but it is it. So yeah. So if anyone have one more question. So okay, I think that's it. Okay, I think that's it. So thanks everyone for coming. And again, the Jupyter Notebook is available on this link. So thanks everyone. Thank you. Thank you guys. Yay. So bye.